Okay, so welcome back. Now what we're going to do is we're going to do a couple of examples and of converting from degrees to radians and vice versa. So first we're going to use the conversion, right? The conversion unit ratios to convert. So here, again, I'm going from degrees to radians. So I want to multiply by the ratio of pi and 180 degrees. That's going to give me radians. Well, then I'm going to want degrees on the bottom. So here's a way to remember, is it 180 over pi or is it pi over 180? Well, the degrees on this case is going to have to go on the bottom to cancel out the degrees. So the 180 degrees is going to go on the bottom, so the ratio I'm going to multiply by is pi radians over 180 degrees. And so what does that give me? Well, that's going to give me pi over 10 radians. Right? Now again, we can write this as a decimal, or we can leave it as an exact answer. And typically, we always write radians in terms of pi because it's convenient, right? Especially when you have pi equals 180 degrees or 2 pi equals 360 degrees. Then typically we will write it. But if you wanted to estimate it, you would estimate it by approximately 0.314 radians. Okay? So you can leave it in exact form if asked to, or you can write it in approximate form by rounding to a certain number of decimal places. Okay, now, what about radians? Now we want to change this one to degrees. So now we got radians on top, so we want to multiply this by radians on the bottom, right, by the ratio that has radians on the bottom. So this is going to be 180 degrees over pi radians. And so the radians are going to cancel, and we get what? We get 360 degrees over pi, right? So this is going to be approximately how many degrees? Well, if we divided our calculator by pi, then we get approximately 114.6 degrees. Now, in the next example, let's just use pi, because again, it is typical just leave things in pi, because then it's accurate, it's an exact answer instead of an approximate answer. So if I do 30 degrees and I want to change 30 degrees to radians, then again, I'm going to multiply this by the unit conversion, the unit ratio, pi radians over 180 degrees. And so this is going to give me what? Pi over 6 radians. Okay, so 30 degrees is the same as pi over 6 radians. Okay, just like 18 degrees is the same as approximately 0.314 radians, or pi over 10 radians. And that's the same as saying, hey, the angle measured at 2 radians is the same as the angle measured at 114.6 degrees approximately. Okay, so now what about this one? Now we want to go from 3 pi over 4 radians to degrees. Well, again, we're going to multiply this by the factor that's going to eliminate radians. So we want radians on the bottom. And so this is going to be 180 degrees over pi radians. And so the radians cancel. And in this case here, what do we end up with? Well, pi cancels with pi. Okay. 4 let's see. So 180 divided by 4 is 45. right? So we get 3 times 45, and 3 times 45 is 135 degrees. So now in this case, the pi's cancel out and we end up with an exact answer of 135 degrees. Now, so I'm going to make a very important point. So I want you to listen. Because pi is a number that is the ratio of the circumference of a circle to its diameter, it is the ratio of one length to another. So what this means is that radians really has no units. Because we typically measure the diameter and the circumference of a circle with the same units. The units cancel out when you take the ratio of those. Okay? And so this means also that radians measures amounts to measuring angles in terms of real numbers. Okay? So it is this property that makes radians useful in many applications. Okay? So therefore, okay, when the angle is measured in radians, it is customary that no units are shown. The radian is understood to be the unit of measurement. So again, what this is basically saying is that we don't need to write RAD every time. It's understood that if the units are not given, when we're talking about angles, when we're measuring angles and the units are not given, it's understood to be radians. Okay? Otherwise, you'll see the degree symbol. Okay? But if you don't see the degree symbol, then assume that we're dealing with radians. Okay? That's also the point to remember. Okay? Okay. See you next time.